Good afternoon. My name is Stephen Christensen. Thank you for coming to Have Your Cake and Eat It Too. Somebody earlier asked me if I would actually be serving cake during the talk. I will not be serving cake. I have no idea how to make a good cake. But what I would like to talk about is how to build applications where you consume data that you do not have or that you do not own. So if you've ever made a map, I want you to think back to the very first map that you've ever made and think about where you got your data from and how you access your data. So I started doing GIS about 12 years ago, and the very first set of maps that I made, we got data from this clunky old data portal online. And then we had this metal shelf that we had CDs that we kept data on. So then you would pull in your data on your desktop app, GIS application, do your analysis, make your map, and then you would print out your map on this 36-inch plotter. And we'll call this pattern GIS Hoarding, where lots of different people have the same data sitting on their desktops. Then we saw the rise of what we'll call enterprise GIS, where you have this kind of central system, and maybe you have workers working remotely, and you synchronize data back to the system. Maybe you have an ETL script that pulls in other data, and you have some good GIS people that analyze some data, publish it, and it gets published to their end users. Then over the last several years, we've been in this kind of frenzy to everybody wants to publish their data over an API, and they want to easily consume other people's data. They want to easily be able to find it and quickly get what they need. And if it sounds like I'm talking about open data, it's not necessarily exactly open data. It's just anything that you have access to. Could be APIs internally, could be something from a third-party source, maybe that you paid for. So just everything is connected. You can easily get to what you want. It's kind of philosophical about why we want to actually, why we like this pattern. But I'll sum it up to say that we're only as strong as the relationships that we make, and I think that looks a lot like this. So I work for mySidewalk. We're in Kansas City. We have a decision support platform that we want city planners and those that work with city planners to use so that they can easily access a lot of data that they need, and quickly make decisions so where they don't have to go and task somebody else and maybe they get an answer, maybe they don't get an answer a long time from now. So we do talk to a lot of city planners, and miraculously they all kind of have the same problem. They'll have the same problems about acquiring data and getting data. So a general conversation might go something like this. They'll say, well, you know, we work really good with the engineering department. They share data with us. They're easy to work with. Our kids play soccer on Saturday, and we just work really good together. But then there's those other guys, maybe it's the engineering department. They don't really like to share data for some reason. They just, you know, it's hard to get stuff from them. When they do get something from them, it's hard to figure out what it means. It takes our people, you know, several hours, maybe days to actually look at the data, figure out what's going on. And then as soon as they send the data, of course, it's out of date. We need to keep getting that data over and over again. So three main problems. Only some of the departments in a city share data. It gets out of date quickly, and that data takes a lot of time to quickly figure out what it means. So one of the problems that we solved late last year in our platform is we built a layer upload tool where a user can quickly upload a shapefile into our app, visualize it along with all the other data that we have in our app. And most people think it works pretty well. Being the guy that built the tool, I get to watch the logs and I get to see how people are using it, what kind of problems they're having. And there's two patterns that kind of bother me. So we're asking a user, which is generally either a city planner or someone that works in their office, not a GIS person, not a data person, to upload a shapefile into our app. So each one of these might be an attempt to upload the shapefile into our app. I tried to make the error messages nice and friendly, but they just keep trying. Didn't quite get there. Hopefully they didn't throw their laptop out the window. Then there's this pattern. We have a feature limit. They just can't quite understand why there's this feature limit. They just keep trying and trying, and then eventually give up. So what can we do to solve this kind of problem? There's a lot of use cases, not all use cases, where we just need to consume some data, analyze it, we produce our output, and then we don't actually want to have their data stored that we consumed. So there's this other pattern known as data federation. Basically, there's two perspectives for data federation. One is from the client's perspective. It looks like they're accessing a data source that's homogeneous. It looks like it's all right there in the database or whatever data source it is. But then the system actually federates database access, so you can actually access any different data source, and the system, in this case PostGIS, handles it through foreign data wrappers. It takes care of that federation for you, and you're accessing a heterogeneous source of data. So let's see an example of what this looks like. So here we have an example query. I've got three tables. I looked at Johnson County's website for some data. They're in Kansas City. So we have some bus stops. We have some zones that I created. Then this other table is zone assessment. So that looks like a very innocent query, some joins. I've got this where clause on low, whatever low might be, maybe low income, and I get my result. But under the hood, you'll see that we've got a couple of foreign scans, and that is actually what each foreign data wrapper that you use implements that data access under the hood. So here's my sequential scan for data actually in my database. Then this is a foreign data source. This is a foreign data source. So using PostGIS foreign data wrappers is fairly simple. Create extension, create server. That's basically the access configuration. So this is using the PostGIS FDW, which actually comes installed with PostGIS. You just need to run create extension. Create your user mapping. Just maps the user on this database when I'm using this specific server to the user on the other database. Then I'm using the new import foreign schema, new in PostGIS 9.5, to get that zone assessment as a foreign table into my database. The other foreign data wrapper I'm using is the new OGR FDW. It's been out for a little over a year, I think December 2014. Again, you want to create server. My data source is actually an Esri web feature service from Johnson County. I'm using the GDAL GeoJSON driver, which a lot of people think you have to have a GeoJSON file. You don't as of GDAL 1.8. It can consume a GeoServices REST specification endpoint. So this is just an endpoint I'm accessing. And there's my create foreign table statement. You could also use a import foreign schema with this foreign data wrapper, but I wanted to give it a specific table name here. So the biggest consideration for foreign data wrappers is what gets pushed down to the foreign data source. You don't necessarily want to get back the full data source over the wire and then have to do something with it locally. You want to restrict, if you can, what comes back so that it's a lot quicker. So in this case, one of the main things that can be pushed down as of now is the where clause. So if you specify, if you restrict what data you want to come back, you want to know what parts of my where clause can get pushed down and what parts don't. In this case, this is the OGR FDW. The spatial operators do not get pushed down at the moment. So in reality, I get the full, for this query, I get the full data source back to my local server. And you can see the query plan. The local server has to filter out anything that doesn't match. So for regular, if you just have attributes that you want to filter out, I've got a where FID equals 3. That does. It's using GDAL's set attribute filter. So I only got one record back to my local server, and that happens a lot quicker. If that doesn't quite make sense to you, here's kind of a graphic way of looking at it. You have your local server, your remote server. You want to ask a simple question. And if your where clause is not getting pushed down, you will get back the whole data source. In this case, it's the encyclopedia. So the whole encyclopedia gets transferred over the wire from the remote server to the local server, and then the local server has to read the entire encyclopedia. He can't stop when he figures out what the airspeed velocity is. He's got to read the whole thing and figure that out. So if the where clause does get pushed down, you return back exactly what you want, and you move on, and it's much more performant. That's all I've got. Any questions? Yes?
Have you used foreign data wrapper to import the data, like to replace that shapefile upload process that you were showing?
Sure. The question was, have we used FDW to replace our current shapefile upload? We have not. We've been using foreign data wrappers internally for about the end of last summer. So really, we're looking at ways to where a user can consume any data that they have within the city and basically pull it into our app using a foreign data wrapper, using data federation. So this is kind of just a something newer that we're basically trying to implement. Anybody else? All right, well, thank you for your time.